Okay, here's problem number 10 from activity 215 moments. And this problem, we have a beam, and this beam has a force acting on it of 500 pounds, about 9 feet over from this pin. And there's a roller on the other side at about 15 feet. So what we need to do with this is calculate all the moments and label the reaction forces at the pin and roller supports. Alright, we're going to basically use this little table over here to solve this out. Okay, first thing we want to think about is that for these problems, it's no different than the other problems we've done so far. The goal is to have a sum of the moments has to be equal to 0. We don't want this beam to move. We don't want it to rotate. We want it to stay put. So the sum of the moments must equal 0. Another thing to think about is that the forces acting on these things, we want the net forces that are acting on these to be equal to 0 as well. Because we want, again, we want it to be in equilibrium. We want it to be staying where it is. Okay, so a couple things we have to understand. We talked about these in previous problems, but we have a triangle here, and a triangle means that we are dealing with a pin. All right, so at A we have a pin. It means that side of that beam is pinned down and it's not budging. So that's our pivot point. Okay, or our pin. So I'm going to draw the forces acting on this pin in blue. So I got a force acting up on it, and we're going to call that the reaction force A, because it's at point A, and it's going up and down, so we're going to call that Y, so that's RAY. Alright, and at every pin we have two reaction forces. We have a reaction force going up, and we'll always start with a reaction force going in as well. It's held down basically in both different directions. Alright, so we're also going to call that R for reaction force AX, because it's in the horizontal direction. Okay, this force right here, we can just call that force C, because it says force CY. Alright, for the roller, rollers only have one reaction force. They're just pushed upwards by that roller. Alright, and we're going to call this RB, reaction force B, because it's at point B. And since it's vertical, we're going to call it RBY. This will not have, a roller will not have a force pointing inwards. Alright, so if you see a little circle or a roller, look up above, you see, in the problem above, you see a little wheel looking thing on the bottom. Those only have one reaction force going up. Okay, so we got that all set up so far. What we're going to do first is figure out what is the moment that this force in the middle is applying to this beam. Right, this force in the middle is pushing downwards. If RBY was not here, and we said this is our pivot point, then this thing would swing downwards, right? It would rotate down in the downwards direction. So it's it's causing this kind of motion, right? Which is clockwise, and we know that clockwise directions are negative moments. So this is going to be a negative moment. You can do the right hand rule to figure that out if you'd like. Alright, so we're going to call moment C, right? Moment C is going to be found by taking the force of CY, which is at 500 pounds, and we're going to multiply it by the distance it is from the pivot point. We're just going to say that this is our pivot point, because this takes away two forces here, and we can come back to those later, so we'll say that's our pivot point. We always want to use our pivot point or start with our pivot point as the thing that has the most forces acting on it, which is this one. So we got a force there. What's the distance that force is acting away from that pivot? Well, it says 9 feet. So it's 9 feet away from that pivot point. So if that's the case, I should have just put distance there because I used the variable there, but let's replace that FCY with 500 because we know that that value is 500 pounds of force. So 500 times 9. 500 times 9 is 4,500 foot-pounds of torque, or a moment of 4,500. But we said that this is going to cause a negative or a clockwise rotation, so we're going to call that negative 4,500 foot-pounds. Alright, so moment C is giving us a negative 4,500 foot-pound moment. Okay, from there, remember, A, B, and C is got to equal 0, right? If I press on A, here, or if A is the pivot point and there's forces acting on that, then it's not going to go anywhere, because if you apply the force at the pivot point, it won't move anywhere. There will be no moment at all, right? So it's kind of like if you try to press on the hinge of a door, it's not going to cause the door to rotate. So the moment at A, which is this area over here, this side of the beam, the moment of A is going to be 0. Alright? So in other words, what moment is RBY going to cause? It's pushing upwards, and what is the moment that it's going to cause be? Alright, well, these three things have to add up to 0. So what could this be that would, help this to add up to 0? It's got to be positive 4,500 foot-pounds of torque, or a moment of positive 4,500. That's the only way, these things would cancel out to be 0 if I added them up. So we know that the moment of B has got to be positive 4,500 foot-pounds. Alright, we know that that's got to be true. So the moment of B is going to be that. We're going to set that equal to an equation. Well, we know that the force, moments of force times distance. The force is the reaction force, so the force is RBY. And the distance that is away from the pivot point, how far is RBY away from the pivot, or the axis of rotation? 15 feet. It's all the way out here. So if that's the case, to solve for RBY, we got to take 4,500 and divide it by 15. The feet cancel out and you're left with pounds. So 4,500 divided by 15 gives me 300 pounds. I can't really see that on the camera. There we go. So that means that RBY is 300 pounds. It's going to be a positive 300 because it's pointed upwards. Alright? Well, FCY, we see that that's pointed downwards, and that's 500 pounds. So I'm going to put that over here as well, but it's negative 500. This is going in the downward direction. You see how these two forces are opposing each other. Alright? So what would, if these three forces have to add up to be 0 in the y direction, what would RAY be? What would that be if these have to add up? Well, what plus 300 would balance, minus 500 would give us 0. In other words, what plus 300 would give us positive 500? Well, we know that's positive 200. So that means that RAY has to lift up with positive 200 pounds. And it makes sense, because if this is lifting up with 300 pounds, then, and this is pushing down with 500, then this RAY, this force over here, the pin has to do, pull some weight as well. Right? So it's kind of like if you're working with somebody to lift up an object. All right, so one of you is got some of the weight, and somebody else has got the rest of the weight. I know, like, when I pick something up with my wife, sometimes I'll get the heavy end and she gets the light end, or vice versa. So, like, you're not going to share the weight equally, is what I'm trying to say. All right, so that makes sense. The last thing is RAX. What would that be? Well, we have no other forces acting in the x direction, and the sum of the forces has to equal 0 because it's not going to move side to side. So that just has to be 0. There's no other option there. There's actually no force acting in that direction. It's just 0 pounds. So we're good. Okay. You may have, you may have to solve for RAX depending on, what forces are acting in that direction. But you have to just remember that, if there are other forces acting in the x direction, they all have to add up to be equal to 0. So you just have to make sure that they cancel each other out. Alright, so you're going to be given some of these problems, some more practice problems like these in a review packet. And it's just a chance for you to practice these things and see how well you can solve some problems. So just remember, the motto, figure it out. Don't give up on it. Try to figure it out, and if it's tough, then see if you can work with somebody else and that can maybe help you. But don't give up on it. Try it. Do your best. And when I come back on Friday, we can work out the kinks. Okay, that's all I got. Good luck, and I'll see you on Friday. Bye.